Hi, my name's Tom Polakis. I'm in Tempe, Arizona, where I run a small observatory, roll off with a 12.5-inch telescope. And main type of astronomical work that I do is asteroid photometry. And I'm going to discuss today discovery of a binary asteroid. So just as a refresher for those who don't know what we do with asteroid photometry, we just measure the brightness on multiple nights. There's a raw light curve, and then we take that and do the Fourier analysis and create a phased light curve. That phased light curve will give us the rotation period. And maybe if we do it enough times around the orbit, we'll learn something about the shape of the asteroid and even its composition. So typically what I do is about 80 images per night, sometimes a lot more, and sometimes a lot less. And you do this for a week or a couple weeks for a typical asteroid, and you'll get your solution. You get your rotation period and a complete phased light curve. So that's my main focus for astronomy research. Here's the asteroid that I was observing, and it's 1803 Zwicky, named after the astronomer Fritz Zwicky. That's a main belt asteroid, but it has a real large eccentricity and inclination, as you see in this diagram. Where I'm showing it in this diagram gives the about the approximate position in its orbit when I was observing it in February and March of this year. So you can go to a light curve database and find out rotation periods that have been published for any asteroid, and it's the main source for that. When you go into the database for Zwicky, you find only one period, and that's about 2.7 hours. And a little bit about this author, Powell et al. In 2020, they went through tests, the exoplanet satellite that I show at the bottom. They went through that data and devised a pipeline where they could find asteroids passing through the field and get rotation periods for nearly 10,000 asteroids, and not quite putting us out of business because there are some problems with the way the data is gathered by the satellite, but a real impressive work nonetheless. So I observed Zwicky in late February, as you see here, and you look at the figure on the left and you'll see 4 nights of data, the fourth one being a little more dense. And in that second night, this rarely happens that you see anomalous data points that are this far off of the rotation curve. So buried in these points is the rotation curve, and this happened. So here's your cyclic variation and the two humps, the two maxima and two minima that you would expect to see in a period of 2.7 hours, which matches Powell's data. And then there's these outlier points. And I've seen these a lot, but usually not this deep. And in the past, I've gotten excited thinking that these might be mutual events, eclipses and occultations by unknown secondary body that's revolving around the primary. So not quite getting excited about this yet. I went out and looked at the test data for that. So here's from that paper, they published their raw and phase light curves for all of these nearly 10,000 asteroids. And you look at the one for 1803 Zwicky, and now you can get excited that you've discovered a binary because you see this very nice periodic every 0.59 days, you're getting an eclipse and an occultation. So the eclipses are the shallower minima. Their cadence is about a half an hour, or it's exactly a half an hour in the test data. So that's good enough to show this, but not to give a real well-defined phased light curve. So that led me to go out a week later after I'd gathered that earlier data in February on March 1st and just spend an entire night and just sit on a single object, on this single asteroid. And so what you see clearly now are the maximum and minima for the rotation. and then you see this deep drop. And that is due to this secondary body, which is pretty large, going behind the primary. So you no longer have its light and you see this dip in the brightness. So that's a mutual event, and it's certainly an occultation. After that, now that you know when this happened and you know that it's a 14-hour or so, 0.59 day, you know that that's regular from the test data, you can create an ephemeris and predict when future ones will happen. So that's what I did, and I could tell that you would see one. Sorry about that. And I could tell that you would see future ones on March 3rd and 4th. There would not be one on the 2nd. So now let's go to this figure. Here's kind of the illustration. I think everybody in this conference at least will be familiar with eclipsing binary stars that show this type of light curve profile, that you'll see eclipses and occultations will cause these dips. And if it's not a flat bottom on these minima, that means it's a partial event, that you don't have some period where nothing is happening when the smaller body is going in front of the larger body, for example. So we have over 400 binary asteroids that are known now, and most of them are discovered by these eclipses, by these mutual events. Now let's go on to the further data. I showed the March 1st data. Here it is on a little compressed scale that shows 4 nights. And here's March 1st. The 2nd, we didn't expect to see much happen. On the 3rd, I knew that we would see, about at dusk would be the minimum, and then it would recover from that minimum and go to just rotation. The big night was going to be the 4th, and the bad news is that we had clouds in Arizona, thick clouds on the 4th, but it was from a trough that was passing through. And I knew that California was going to be clear on that night and 300 miles to the west of me. And Bob Stevens was great that he had very short notice did photometry and took images from that night. And dense data shows very clearly event. This one's an eclipse event. And having that, I thought, now we really have enough to put together very good phased light curve from it. And that's what you want. First, before I show our data in light curve form, let's look at the test data. When I reduced it, here's the rotation period that they derived based on their photometry, 2.733 hours. And what they missed in their data is orbital period, and that's 28.5 hours. Again, you see these mutual events at half of this rate because you'll get an occultation and an eclipse in every orbit. So they have a pretty good light curve, but I don't like how this is modeled here. You just don't have enough data when the cadence is a half an hour. So here's the Polakis Stevens data, rotation period 2.7 hours. You expect that to match what Powell et al. came up with. And here's that orbital period, which also matches, but is modeled more clearly, where you can see the deeper occultation and the slightly shallower eclipse. And over on the right here are all of the nights that we observed, that we took images. And so here we have a pretty clear light curve that shows orbital and rotation periods for this binary asteroid. Again, back to this figure, a couple things to describe. You can tell from the amplitude that the asteroid is not very elongated. If it was strongly elongated, you would have real large amplitude. And the depth of the eclipse alone can give us a pretty good idea of the size of the companion of the secondary body that's going through the eclipses and occultations. And so we came up with about 1/4 of the diameter of the primary. And that's not an exact number, but at least you can estimate that, since, as I mentioned earlier, since you don't have flat minima, that means that you have something like what's depicted here, where you have partial events. And this is actually pretty close to being to scale, this figure that I made here, where this is about 1/4 of that diameter, and this is about the semi-major axis as well. At the end of this, what you do is run this by the expert in these matters, and that's Peter Pravich in the Czech Republic. And he took my data and then reduced it with his techniques, his dual period analysis, and just slightly changed the values, made them a little bit better. And then he also, since he's done this quite a bit in the past, he wrote the Central Bureau Electronic Telegram, so called the circulars, and he wrote this and shows the three people who are involved with it and gives the idea of what the revolution, what the orbital period is and rotation period, and he can tell you some more about that. So this is on the CBAT page. I took what I knew about the masses and the period, and that's all you really need to know to compute the semi-major axis. So I wanted to know what's the actual size of the orbit, what's the diameter, or what's the radius of the orbit. And what I came up with was 29 kilometers. That's an angle at maximum elongation of about 3.5 hundredths of an arc second. So we know that we can't resolve these two. The only way that you would be able to do this, not by direct observation, but by photometry. So another case where that's the only technique that works due to the distance and how small that orbit is. So I decided to take this and overlay it on Southern California. What does that look like? And, you know, we used to have these conferences before the pandemic in Ontario near the airport, and there's downtown LA. If we overlay the asteroid, primary and secondary body, it conveniently works out to about the same distance from downtown LA out to Ontario airport. So if that's in the test data and it was missed, that they didn't discover the binary asteroid, then we should be able to look at other asteroids and look for the same signature that I showed earlier, that you have these nice periodically spaced deep minima compared that are overlaid on the rotation. And sure enough, I went through far too many, than I care to admit, thousands of these light curves that are all in PDFs form, and found these, discovered two more that have yet to be characterized as binary asteroids. And so none of this has been published or anything. And I found that 6764 is going to come to opposition in early May. And this was really nice that I solicited observations from Southern Hemisphere asteroid observers, and specifically Milagros Collazo in Argentina and Julian Way in Australia. Gave me 10 nights of data, which is terrific. That's not what we're looking at here. This is the test data that shows the two periods, the 4.74 hours and the deeper eclipse and occultations. And what I wanted to see was, now that it's at a different place in the solar system, what will we see as far as the depths of these, or will we see them at all? And none of this has been published yet either. But after these 10 nights of data, which were only done a couple weeks ago, in the past couple weeks, we didn't see any of this drop. So for the same reason that you don't see lunar and solar eclipses every month, you won't see these mutual events at each point in the solar system, because it's inclined to our line of sight. So within the precision that we had in our photometry, we just don't see the mutual events. And that's still good information to have, because hopefully at the next opposition, we'll be able to have another shot at it. Here's 6562. That one's 2 magnitudes fainter, and it's going to be difficult, again, very far into the southern skies, like down in Sagittarius, magnitude 17. Hopefully we can get some observations of it as well. As you can see, it has a real deep 4/10 of a magnitude drop for the occultation events. So it's a large body, the secondary body in that case. I was happy that this asteroid number was 1803 Zwicky, because Fritz Zwicky is a very interesting professional astronomer and first person to come up with dark matter and neutron stars, as I show in those bullet points. And also, if you ever use the term supernova, that's Fritz Zwicky's term. He did a lot of great research and just had this intuition that many other astronomers don't have. So he's genius in that respect, and he's also quite the character. Here's a couple things that he had people do and that he said. And my favorite of those is that he coined the term spherical bastards. This is in the Urban Dictionary, and those are bastards when looked at from any side. So that's my presentation. Hope you enjoyed it. It looks like I went 16 minutes. So I stayed under the 20-minute maximum, and I'll stop the recording and take questions now.